Hello, viewers. In today's class, we are going to discuss two important problems from definite integrals involving the greatest integer function and the fractional part function, right? So here, these two problems are going to be very beneficial for the beginners, right? And here we'll see how easily we can solve these two integrals by making use of the definition of greatest integer function and the fractional part function, right? So let us start, and let us first take the integral number 1. So let us consider this integral as I, right? So here we have the limits 0 to 1, and the integrand is e raised to greatest integer of x minus the fractional part of x, right? So the curly brackets shows that this is fractional part function. So here what we will do, will express the fractional part function in terms of greatest integer function, right? So fractional part of x is defined as the difference between x and the greatest integer of x. So if we substitute this value in this integral, then I becomes 0 to 1. We have e raised to greatest integer of x minus, and here we have x minus greatest integer of x, right? Okay, now let us simplify it. So we have 0 to 1, e raised to greatest integer of x minus x, then we have plus, minus and minus becomes plus, and here we have greatest integer of x, right? So this is 0 to 1. We have e raised to 2 times greatest integer of x minus x and dx, right? So this greatest integer of x plus greatest integer of x get added, and we have 2 times greatest integer of x. Now see, here the limits of integration vary from 0 to 1, right? And always remember that whenever we come across with greatest integer function, then our prime objective is to search for integers, right? So here the limits of integration are from 0 to 1, and we see that there is no integer lying between 0 and 1, right? So when x lies between 0 and 1, then the greatest integer of x should be equal to 0, right? Because here the value of x, it lies between 0 and 1, so the greatest integer of x should be equal to 0 by definition of greatest integer function, right? Say for example, if we have, say, x is equal to 0.5, and 0.5 lies between 0 and 1, so the greatest integer that is less than or equal to 0.5 is obviously 0, right? So here the greatest integer of x is 0. So now we have 0 to 1, and we have e raised to 2 times 0 minus x dx. So this is 0 to 1, and we are left with e raised to minus x dx, right? So now the integral of e raised to minus x is minus e raised to minus x, and the limits of integration are from 0 to 1, right? So now we have this expression, and substituting the limits and taking the difference, we have minus, we can take this negative sign outside. So we have e raised to minus 1 minus e raised to 0, e raised to minus 0. So this is minus 1 over e, because e raised to minus 1 is 1 over e, and e raised to 0 is 1, right? And multiplying these two terms by negative sign, we have 1 minus 1 over e, that is e minus 1 over e, where e is the exponential number. So viewers, the value of this integral is e minus 1 over e. Now let us take the second problem. So now let us consider this integral as I, right? Now see, here the limits of integration are from 1 to e, where e is the exponential number, and the approximate value of e is 2.71, right? So here we have this real number line, and here we have 0, here we have 1, and here we have 2, right? And e lies between 2 and 3, right? So 2.71, it lies somewhere here, right? So here we have e. So now we have to integrate log of greatest integer of x from 1 to e, right? And between 1 and e, we have this integer, right? So whenever we come across with the greatest integer function, we always search for the integers, right? And integers are the points where we can break the limit. So we can now write this integral as a sum of two integrals. So from 1 to 2, first we'll go from 1 to 2. We have log of greatest integer of x, and then we have 2 to e, right? 2 to e, and here we have log of greatest integer of x, right? So now let us first consider this integral, right? Now see, here x goes from 1 to 2. So x lies between 1 and 2. And from the definition of greatest integer function, any number which lies between 1 and 2, the greatest integer of that number should be equal to 1, right? See, for example, if we take x is equal to say 1.3, and 1.3 lies between 1 and 2, then the greatest integer of 1.3 is equal to 1, right? So here for greatest integer of x we have 1, and similarly here the value of x, it lies between 2 and e, right? And e is approximately equal to 2.71, right? So any number which lies between 2 and e, the greatest integer of that number should be equal to 2, right? Say for example, if we have x is equal to say 2.1, then the greatest integer which is less than or equal to 2.1 is 2, right? So here we have greatest integer of x as 2. So now this integral I can be written as 1 to 2, and we have the natural log of 1, because greatest integer of x is 1, and here we have 2 to e, and here we have natural log of greatest integer of x, which is 2, right? So now this integral disappears because log of 1 is equal to 0, right? So the value of this integral is 0, and we are left with only this integral. So we have 2 to e, and we can take this log of 2 outside the integral. So here we have dx, right? So now the integral dx is simply x. So we have log of 2, and we have x, the integral of dx, and the limits are from 2 to e, and we have log of 2. Now substituting the limits and taking the difference, we have e minus 2, right? So the value of this integral is equal to natural log of 2 times e minus 2, which can also be written as e minus 2 and log of 2, right? Or in other form, we can also write it as log of 2 raised to e minus 2, right?